Hello and welcome to another edition of the RotorHub International podcast with me, 𝗂𝗍𝗄𝗯, the editor of RotorHub International. This one's another one recorded here at VertiCon in Dallas. Joining me now are Mike Martin, who's the VP Training with Air Rescue Systems, and Cody Berg, who is a hoist instructor. So we're going to learn all about serious hoisting stuff with the 𝗂𝗍𝗄𝗯 system, which I've seen. If you haven't seen it, well, you'll be impressed too. Guys, thanks for spending the time to sit with me this morning and walk me through some of the background and some of the capabilities of the system.
Absolutely. Thanks for having us.
Appreciate it.
Yeah.
Let's just talk and start with that whole background of the system, the genesis of the idea, and walk me forward through that.
Yeah, it's interesting because ARS and 𝗂𝗍𝗄𝗯 have different histories. ARS has actually been around for 20 to 25 years, started off as an actual rescue organization in Oregon, compared to 𝗂𝗂𝗃.
So 𝗂𝗃𝗃's been around about 8 years as a small company growing into a larger company. Started out with a rescue team on the ground. Our CEO was part of a rescue team that had a mishap with one of their own team members. While they were trying to extract him, the helo got winded out, and it inspired Caleb to develop something that would allow rescuers to operate in tougher conditions than current trail line and just simple straight up and down hoist is allowing for. So that's where that came from 𝗂𝗃 Rescue Systems and 𝗂𝗃𝗃𝗃𝗃𝗃𝗃.
So let's go a little bit further forward because like I say, I've seen the system, but a lot of people listening haven't. What makes it so special?
Well, like I was just saying, it allows operators another tool to use during tough conditions for hoists. So if you're seeing high winds, either from environmental winds or from aircraft-induced winds, you're stuck in a static hover, for example, and you can't use dynamic techniques to get out and get forward airspeed on your aircraft and on the litter. That 𝗂𝗃 Rescue System provides that load stability for those operators, and that's one example of how that system would work to help folks out.
So let's just delve a little bit more and explain to the people listening how it does that.
Okay.
Because that's the thing. I mean, I've seen how it does it, but I want others to understand how that works, how you get that stability without, as you say, translation and
right.
all that kind of thing.
All right. So the system has multiple accelerometers, and I'm a dumb operator. I make the thing go. So our engineers will probably scream at me once they hear this. But the short version is we've got multiple accelerometers that detect deflection and motion around what the system considers its 0 point. So if it feels sway or spin or swing, it will activate its fans. It has 4 fans on the corners. It will activate its fans to stop components of that movement until all of those components stop. So if it's spinning and it's just a spin, it'll activate 2 fans on opposite sides to stop that spin. If we have a complex movement like a oscillation or conical oscillation with rotation, it will rotate itself, stop one component of that movement, so it might stop the spin first, so now you just have conical oscillation. Yep. And then it would rotate itself again and stop one component of that conical oscillation, so now you just have sway. And then it would rotate again and stop that sway. And ideally the system is designed to get to 0 point underneath the rescue hoist and keep that line as straight as possible, so that your hoist operator can all they need to do is focus on getting the line up and down.
So let's talk a little bit about the training, because obviously you've suddenly got this intelligent piece of kit on the end of the line. Mm-hmm. What are the challenges you've seen in getting operators to understand the capabilities of the equipment and how they can change their working environment?
Okay. So the most difficult part for training that I've seen so far, and I've trained with a handful of units, the most difficult part of training is just reminding operators to, as part of their checklist, hey, push that button. It is that simple. If you push the stabilize button on the system, it will stabilize itself as you're hoisting, and just getting that into your flow, either as a verbal part of the checklist or as a hoist operator. Okay, this is part of my steps. I see my pickup signal. I'm hitting the stabilize button, and now I begin my hoist.
Yeah, so just hit the button, and then I'm back to doing my job, and
correct.
I don't have to think about that anymore.
Correct.
It's now, I'm the dummy, and it's the smart plug. It's,
yes.
It's stepped onto that. Have you found any sort of tendencies for people to try and think about still applying earlier techniques they might have had for counteracting sway, spin, whatever?
Yeah. So the great thing is about the system is that you can still use those techniques. Those are tried and true techniques that that hoist operators and helicopter operators are familiar with. Moving the aircraft over the load during a swing still works with a system like this. You just don't need to as much because the system is dampening those movements before you have a chance to react.
Right. Yeah. So you've got, and also you have a thing like confined space, and you don't want to be shifting the rotor system around. You don't have to think about it. It's again,
Yep.
nulling it out without those sort of inputs. But what about challenges that you might have seen in operation? Have you encountered anything, or is it just doing exactly what it said on the tin?
Well, it's all about adding extra options too. So these are new options to give to these rescue organizations, and it's the same thing that we incorporate into our training as well. Our training is giving these search and rescue organizations more options, and depending on the unique environments that they'll see themselves in, every organization has their own unique challenges, whether it's like the geography itself or the terrain, the people. All these things factor in to make those. No rescue is the same, even for the same organization. So we enable different options. We enable that foundational knowledge of how to conduct these rescues safer and more efficiently to help them out and make them safer. The end goal is to make these safer and more efficient. They pick and choose what their programs need from what we teach and our equipment that we offer, so that way they can accomplish the mission. That's the main goal.
So that dials it back, and we can sort of encapsulate it as a system that makes completing the mission successfully and safer is the fundamental. That's the goal.
That's the end goal, and that's the
goal.
whole company. It's nice to work in an organization that's always the end goal. Help save more lives and help the people that help people. That's kind of what drives all of our technology, our equipment, and our training, and that's how they all kind of line up together. You can pick and choose as customers what you want, but at the end of the day, we just want to give those options to people.
Yeah, and that helping people who help people succeed in their tasks and their missions.
It's a real easy mission to get behind.
Yeah, really. Isn't it? Guys, thanks a whole lot for spending the time. I know it's like all these shows, it's always very busy, and thank you very much for spending the time to come down and just give us a little bit of a brief on it.
Yeah.
Because I've seen it, as I said, and it's a seriously impressive system. Guys, thanks very much for spending your time. The clock has beaten us. But there we are. Soon we'll be going home. That's been another edition of the RotorHub International podcast, live from Verticon in Dallas. Until the next time, fly straight, fly upright, blue side up.